Now we consider about the object-oriented characteristics in the language Eiffel. Polymorphism. Eiffel allows entities to be attached to different object types at runtime. Polymorphism in Eiffel is constrained by inheritance. Only those objects that conform to the declared type are allowed to be attached. Conformance of an object includes its declared type and any direct or indirect descendants. For example, given class A and subclasses of A being B and C, an entity declared as entity A can be attached to objects of type A, B, and C. Static typing ensures that there will be at least one version of all operations requested by a class. Encapsulation. Features can only be invoked through the public interface of a class. A class public interface consists of all operations and state that are exported. Exported features are public and can be invoked by any class. A feature can also be exported to a select set of classes. For example, a class may appear as shown here. Here, attributes A and B are exported to any, and therefore all classes that are descendants of any. Attributes C and D are public to only class A, B and C, while attributes is exported to no class. Attributes can be exported in a read-only form. This is different to Smalltalk and other similar languages that cannot make state directly accessible to the public. The implementation details of all operations are hidden in the public interface. Only the signature and optional header, comment, and the pre and post conditions are available in the public interface. Attributes are functions with no arguments, also appear identical. When inheriting, there is no form of encapsulation. An inheritance relationship inherits all features unconditionally. The export status of inherited features is also inherited. However, this export status may be changed in the descendant. In Eiffel, inheritance is a powerful and attractive technique. This is the syntax of inheritance class. Eiffel uses a multiple inheritance model. Subclasses may inherit from one or more superclasses. A class may also inherit from one class many times. This is repeated inheritance. Let's look at a little example of inheritance. To make a class inherit from another, simply use an inherit clause. This makes D and higher of A, B, and any other class listed. Eiffel supports multiple inheritance. A class may have as many parents as it needs. By default, D will simply include all the original features of A, B, to which it may add its own through its feature clause, if any. But the inheritance mechanism is more flexible, allowing D to adapt the inherited features in many ways. Each parent name, A, B, in the example, can be followed by a feature adaptation clause with subclasses, all optional, introduced by keywords rename, export, undefined, redefine, and select, enabling the author of A to make the best use of the inheritance mechanism by tuning the inherited features to the precise needs of D. This makes inheritance a principal tool in Eiffel process mentioned earlier of carefully crafting each individual class like a machine for the benefit of its child. Let's see why our next project should use Eiffel. If we talk about the reusability in Eiffel, is the only approach that has taken this requirement and its consequences all the way to the end. Eiffel benefits here from being a simple and consistent design. not the transposition from older, unrelated technology. Beyond the language and the environment facilities such as pre-compilation, the crucial help to reusability is, of course, the presence of thousands of high-quality library classes such as in ISE Eiffel. There are EiffelNet for client-server communication, Eiffel Store for relational and object-oriented database manipulations, EiffelLex and EiffelParse for lexical and analysis and parsing, EiffelMath for object-oriented numerical computation, EiffelVision for portable graphics. Well, WEL, the Windows Eiffel Library for Windows-specific graphics, EiffelWeb to process forms from the web, and many others. Not even mentioning quality, the result is probably the biggest repository of object-oriented components available elsewhere. The care that has been applied to the production of these libraries also has considerable periodical benefits. The way people learn Eiffel is by learning the libraries first to use them, then to adapt them if necessary, then to write their own software. If we consider about extendability with Eiffel, modifying software is part of the normal process. Chief among the methods support for extendability is the careful design of the inheritance mechanism. Unlike Smalltalk, which is fatally limited by the absence of multiple inheritance, the Eiffel approach fundamentally relies on multiple inheritance to combine various abstractions into one. Performance is almost as much as obsession in Eiffel as reusability. The software field is still and will remain for a long time largely driven by performance considerations. With Eiffel, you can have the best of the worlds. Thanks to a performance-obsessed language design and 10 years of research and competition on compiling algorithms, the speed of Eiffel generate code is as good as the of hand-produced C code or better. A good way to think about Eiffel, the steaminess of it, the insistency on getting everything right, the conviction that software should be beautiful in and out, the specification and implementation. Hundreds of thousands of people have now been exposed to Eiffel through books, through courses, through hearing about other people's successes, and most importantly, through using it to complete a project on time, within budget, and to the satisfaction of their customers. Shouldn't your next project use Eiffel too?